G'day, welcome back. Today I'm finally starting my new series on corresponding squares, which I've likened to chess's version of quantum entanglement. Now you'll understand when you see some of the positions where a move by white on one side of the board requires a very precise and exacting corresponding move by black on the other side of the board. You'll see how the concept of action at a distance really does seem to apply in this instance. Now, I'm doing this series because I've always been fascinated by this part of endgames, and I think for all of us, it'll really help to be able to, study these positions, enjoy the sort of the what the solutions imply, and also just generally help you improve your board sight and endgame play. Now, speaking personally, right, corresponding squares also have a lot of sort of a mathematical basis, which I find quite interesting as well. I mean, there's elements of set theory. And graph theory with the transition states, functional mappings from one space to another space, a lot of predicate logic in there. And overall, obviously we've been using a few programs to help us on the way. There's a number of algorithms which people have done to help analyze different corresponding square positions. Now, if you have a look at the background of the thumbnail there, you can see that there's the famous Lasker-Reichhelm position there, which, it actually has 10 pairs of corresponding squares. It's absolute madness, right? Now, as we go through this series, I'm hoping that's where we'll get to. We'll get to Lasker-Reichhelm and then, say, 10 pairs of related corresponding squares. Now, is that the most? I mean, that's something maybe we can find out and see if we can find other positions. I'll just quickly also describe this Venn diagram. This is the only position we're going to look at today. This is just an introduction to sort of get you whet your appetite. So here's a position where if white has a pawn on the d6 position, and if you have a look at this, there's a few elements here that if white is on c7, d7, e7, they're key squares and white will win. If black gets to d7, that should mean he draws. And then the other sort of the overlap in the Venn diagram is actually the corresponding squares we are talking about. If white is on c6, black needs to be on c8. If white is on c5 or d5 or e5, black needs to be on d8 or d7. And if white is on e6, black has to be on e8, right? And then as white transitions from those different squares, e6 to e5, black needs to make the corresponding move. So that's just the quick introduction. We'll go over that position in more detail at the end of this video. So corresponding squares, just through this series, what sorts of things are we going to cover? I mean, mainly we're covering pawn endgames. One side has pawns or blocked positions. We'll see quite a few of those. When pawns move, the corresponding squares change, so you have to bear that in mind. So blocked positions are sort of an easier subset to cover. Now, we'll just quickly say definition of a corresponding square, like they're matched squares as I described before. The defender must move onto the corresponding square the attacker has moved on to be able to draw. That's the normal situation we're looking at. I draw on a number of sources here. You're welcome to look at these yourself. Wikipedia has a very good section on pawn endgames and corresponding squares. I have 3 books in particular which help me. Karras, Practical Chess Endings, I believe. Lamprecht and Muller, Fundamental Chess Endings, and I've got the Dvoretsky book on tournament play, I believe. But you will find corresponding squares mentioned in most endgame manuals anyway. I've got a Spielman book which has a few pages on it as well, right? So you'll definitely find a lot of material out there if you want to do further study, and there's quite a few YouTube studies already looking at corresponding squares. Just a quick sort of aspect on terminology. We're calling them corresponding squares. Lasker-Reichhelm originally called them sister squares. Karras calls them relative squares. So they're all the same thing, and we'll be talking about them. As we go through, what we'll find is that opposition and triangulation are kind of subsets of corresponding squares, and I'll try and highlight that when that occurs. And there's other types of squares which are also quite important. Key squares and critical squares. We'll have a look at those as we go along, right? So our destination, as I said, we'll get to Lasker-Reichhelm in the end. So today, what I want to try and do is just process one simple example. As I said, that position in this Venn diagram with a single white pawn on the d6 square. Okay, so I'll just move over to the board position, nothing there at the moment. And now we'll go through a sort of a simple process of understanding how you work out the corresponding squares. Now, the first step is always, we'll take it from White's perspective, is finding those squares which White, if he gets his king on it, he will be winning, no matter whose move it is. Now, there's a lot of endgame material telling you the corresponding squares for different king and pawn endgames. Now, what I've done is I've written a Python script using Python chess. I've done a video on Python chess. Maybe a good idea to go and watch that. So this script I've written, it is given a pawn position, a pawn structure, and then it basically tests all the positions using where the white king can be and where the black king can be, given legal positions, and tells you if the position is winning for white in all black king positions or not, right? And this is done. I'm using the syzygy, probing the syzygy endgame table base. Once again, I've done a video on syzygy, so you should, if you haven't already, please take a look at that, and you get an idea of the sort of the different tools that you can build using. Well, this is open source software, and it helps you do your analysis on unintended positions. So, as luck would have it, I have that script. Just run this probe run, that's what I call it, and it probes that position. You can see the pawn on d6, which is the position we were talking about on the Venn diagram earlier. The top chart shows you the 6 squares, which are key squares. I mean, of course, we're ignoring positions where black could simply take the pawn, and the relevant ones there, I mean, of course, the 8th rank ones are key squares, but C7, D7, and E7 are the main key squares to think about. And I've done a second chart there which shows you the positions which if black achieves that position, then he's drawing no matter where the white king is. And you can see, so D7 is kind of a magic square in a sense, because it's a key square for white, and it's also a key square in inverted commas for black also. Now, with a little bit of luck, I can just paste that script, generates a Venn for me, and there it is. It's pasted in. Okay, good. Ready to go now, right? Okay, so first off, I'll just mark the key squares, C7, D7, and E7. Now, I think it's fairly trivial that if your king was on one of those squares and you had the pawn there, you would just shepherd the pawn forward. So we don't need to cover that. So now that we've got the key squares and we understand the key squares and we understand why we need to get there, we now go a step back to the corresponding squares. And the idea is you actually map out different squares where the white king is threatening to move to a key square and the black king has to defend against that threat. So, for instance, let's take if the white king was on C6, right? From C6, the white king is threatening to go to C7 and D7. Okay, cool. Now, you'd think there's actually 2 squares that the black king could be on to cover those squares. Could be on C8, it covers both those squares, and also D8 looks like it covers both of those squares. But there's one drawback here. Yep, okay, good. So, just had to do a triangulation there, you saw. Now, if the black king moved to D8, so that's if D8 was a corresponding square, you'd think, oh, that's great. But the problem here is that, remember I said if pawns move, then the corresponding squares change. So the winning move here is that white would push his pawn. And in this particular position, black is now forced to concede, and white moves up to the key square, because black cannot go there because the pawn's attacking that square. So what we've concluded there is that in this position, the only corresponding square for C6 is actually the C8 square. And we can use the same logic on the other side of the board with E6 covered by the E8 square. So what we now have is we have our first pair of corresponding squares. So that's square 1 and square 1, and this is square 2, and yep. Right, so that's sort of the first step of the analysis. And now you go to the second step of the analysis. What other squares can the white king go to where he's threatening either key squares or corresponding squares? Now, the logical square to look at now is D5, the square behind the pawn. Now, on D5, you can see white is threatening to go to both C6 and E6. And, there are basically 2 squares which black could be on in this situation. I mean, obviously there's this magic square of d7, which I've said if black's on that square, you can you can draw with best play, right? So d7 covers both, and then black can also be on d8 because from d8 black can both cover the first corresponding square and the second corresponding square, depending upon which way the white king moves, right? So I hope that's clear that there's actually two squares he could be on at that stage. And so what we're going to do is this is going to be the third, and then we can call both of those the sort of the third matching pair of corresponding squares. So this is where quantum entanglement fails, because often it's not a one-for-one relationship between squares. However, so there we go. What I've tried to do there is you can see that after you do the key squares, you do this sort of retrograde backfilling of the squares, and actually there's not much need to go further. I mean, we can just I think these are all considered as you cover it with by being on the third square, which actually is good practice in a real game. Basically, you would be oscillating between those two squares, and then as soon as white pops into c6 or to e6, then black has to oppose. This is an example where opposition also works. You need to take opposition at that last level when white's king moves to 6th rank to protect yourself. So you can see, actually, I'm just going to point out very briefly, you can see I've sort of added some sort of functionality to SCID. I've done a video on a SCID versus PC and how to sort of edit the code. So that's why I'm able to sort of bring up some of these charts, which I hope are a little bit more explanatory, because I can actually mark the square numbers and so on. Okay, so I think that's all I really wanted to cover today. I hope to give you a bit of background of where we're headed in terms of the corresponding square video series, and then I've shown you a couple of the tools which I've been building in my other video series for Python script for working out which squares are key squares, and then being able to visualize it on the GUI. So, I mean, we were looking at this Venn diagram earlier, and I think you can see how that matches what we were just playing out on the board. Okay, look, this is going to be a long journey for sure. Thank you for watching. Hope you enjoyed it.